There we go. Welcome, welcome. Hello. Saturday morning. Let's see. I think we're good. Dang, I've got so many projects going on. Hey Xavier, how's it going? For the 2D visibility project, I was thinking there's two ways to approach it. We can either build the raycasting ourselves, doing intersections and stuff, which would be cool. But it's really not meant to, it's not like meant to be a raycasting demo. So we could also, since like Avian already has raycasting, turn these into colliders and then take advantage of spatial query, right? It's not this, it's this. Take advantage of Avian's infrastructure for raycasting. To do all the raycasting. I haven't come to a conclusion. I don't know which is better. I feel like this example was meant to be something else. This example wasn't really meant to be a raycasting demo in particular. It was meant to be like a how to shove positions into a mesh kind of example. And to do anything useful with this mesh, we also have to do either a custom render phase and a post process, or an extra camera for the mesh and a post process, or something like that. So there's already a decent level of complexity. So yeah, I don't know. We committed it on stream, so it's got a, like, the current version of it is up on GitHub if we ever want to go back to what it does. So we can just kind of mess with this. If we do manual raycasting, it's going to be extremely naive, right? There are ways that we can build up bounding volume hierarchies to make it a little bit like quicker to raycast through everything and whatnot. But like, then the question becomes like, how far do you go down the optimization path for this example, right? Because if we do our own raycasting, then like first implementation is probably take the ray to every vertex, normalize that, use that as a raycast for all walls. Which means doing a lot of cross product. So for every vertex, we would iterate over every wall in the scene, which we have plenty of like headroom to do in our current scene. And I think for 2D, that may be fine anyway. Like 2D stuff tends to have fewer vertices than 3D stuff, right? If we were doing raycasting in 3D, like a sphere has significantly more vertices than a circle. So that might be fine. The thing I'm kind of like coming to is this is there's multiple implementations that can go down here. So we have a Mesh 2D implementation with manual naive raycasting. Something I don't know if OBVHS actually would work for us, but like or we have Avian Collider plus raycasting as another option. If we do OBVHS, you basically need to build that structure for a bunch of things, and then it's like more optimizations on top of that, right? There's static stuff and there's dynamic stuff, and there's I don't know, raycasting can get pretty deep. So I think actually what we do is probably the naive approach. Like somebody comes in and doesn't know how to raycast stuff approach. And then we can have another example that is like actually a raycasting example, like how to write the raycasting and not how to yeah, because there were two approaches that I wanted to take with the meshes too. The meshes were like we can either create a mesh and keep stuffing these vertices in, but I also wanted to like potentially build our own pipeline and then show how to pass those vertices into our own pipeline. So like, I don't know, there's a lot of like directions this can go. And figuring out which one is the most useful for people is interesting. I think the avian approach might end up with the least amount of code, which in general is good for people who are newer. Because even with our like little kind of not great implementation here that tries to skip some stuff, it's still a couple hundred lines of code. So yeah, thoughts. I think either way, we probably get rid of the code we currently have and start from just visualizing. Hey, Rootster, how's it going? Just discussing kind of what I want to do with this example. There's a couple ways it go. 2D visibility mesh example. The questions basically being, there's a couple of implementations we could go through. If right now we're using mesh 2Ds to pull all the vertices and kind of do like a manual like pseudo raycast to every vertex and stuff. We need to do real actual like raycasting. Once we do real actual raycasting, we have to iterate over a lot more points. Not in this scene. This scene only has like 16 points, but I think it would still be fine performance-wise, but there are optimizations we can do, like building up bounding box hierarchies. So like we could get into OBVHS, or we could do something even more like on the basic side and kind of treat this as more of an introduction to like avian and raycasting. So like less about the implementation of raycasting and more about the usage of raycasting. I think all of these are valid and useful. I don't know if maintaining 3 separate visibility 2D examples is worth it. And then there's the other thing, which is like, how do we actually construct the final viz mesh? Which right now we're doing just fine, but Your idea was to use the code we already have, fix it, and use it to draw a visible area or a color gradient or fake lighting. Yeah, but to fix the code we already have, we have to actually implement raycasting. We have to do line intersection or line segment intersection. So for example, this line right here, right? This has to extend to the edge. Why did that change? That was weird. Was that like floating point inaccuracy in action? That was wild, right? Maybe it just changed resolutions and that it was delayed a little bit or something. Wild. There's a couple of different like problems, right? We actually have to do raycasting. We need to project a vert onto an edge. Yes, we do need to project a vert onto an edge, but we also have to solve this problem. And I don't see how we solve this without doing like the raycast to that point to intersect with the wall in front of it. Right? Yeah, I have to find which edge. And the edge could be further back or further up, right? At which point we basically have the definition of a line edge or line segment intersection. Hey, Rubby, how's it going? Right now, we're kind of discussing what I want to do with this 2D visibility example. I've covered it a couple of times, but TLDR is we're in a point where like technically it works, right? Like things here work in a sense. And that sense is that we do a 360-degree sweep around all the vertexes sorted by angle. We do a construction of a bunch of different triangles. So if I hit space, you can see the wireframe for the mesh that we're creating. Anything yellow is the visibility mesh. So you can see, well, if I pull that away and I start doing this, you can see that we're iterating over these vertices by this green line, basically. This is reverse to create this mesh. So we go from player to point. We go to the next vertex through like a little bit of an optimization, actually. The winding order for meshes in Bevy for the face is counterclockwise. So if we just add one to the index of the vertex and turn that into an infinite loop, we can just directly go to the next vertex, which is really cool. So we do that. And then there's a little bit of jumping here. But there's a couple of problems with this approach. One of them is that if you are inside of a rectangle, the like speed hack that I used for going from this bottom left vertex to the bottom right by increasing the index by 1 doesn't work because you're inside of the rectangle. And that goes in the opposite direction then. And the other big issue here is that we need to project, well, it's a double-sided issue. We need to project like the vector from the player to this bottom left corner to the wall, right? And we also need to fill in this left triangle, but that's a different issue. So like this box should be casting a shadow defined by this vector or this line going up to the edge and this line going out to the edge. And back here should be shadow. I assume you can see my cursor, but it might be a little tough. So to do that in this case is relatively simple because it's a relatively constrained example. So like if we know we have one box and we know that we have to raycast past the edges, then it's really easy because we just project forward onto the other line and we're done. The issue comes in where we end up having like things like this are still an issue. So right now, this is raycasting to the bottom left and top left of the red box. But it's not actually doing intersection tests against all the walls. So we end up with trying to get to a vertex that is sorted by angle, but is not actually a vertex we can reach because we aren't doing like actual raycasting. So we don't get away with like a cheap version of, hey, just project these lines. We actually have to do some kind of raycasting and intersection tests here. So the question then is, if we actually have to do that, if this actually does have to become a raycasting demo, do we do that as a raycasting demo, or do we do that to do the 2D visibility mesh, but use something that already built raycasting for us? And Avian is one of those things where if we, let me get rid of this. If we take advantage of Avian, Avian already has, this is BVH, Avian already has spatial queries built into its system, right? We can cast rays. It has the benefit of teaching people like the Avian APIs, which I think is really valuable. It probably gives us, it gives us a pre-existing raycasting implementation that we don't have to write ourselves. So we don't have to distract from the 2D visibility mesh demo to do a raycasting demo. Not that either of those are wrong. I'm just kind of making the decision. Xavier, the more you think of it, the more you finding which edge would basically be ray tracing. Yes. We have to do like line segment intersections for everything. And I think that's the real crux of the issue. It does have to actually be a raycast. Bevy stream every day. What a treat. Yeah, I think I'm going to do this next week too. I've been enjoying this. TBD on what we end up doing next week. I'm going to start doing more of the workshop development streams, I think. The workshop development streams people seem to really enjoy, actually. So I don't know if y'all will enjoy like the actual scripting on stream, so I might do that off stream. But coming up with the new examples and stuff is something that people seem to really enjoy. Coming up with the new topics for the videos and stuff. So we'll probably keep doing that on stream, and then I'll leave maybe more of the intense scripting to off stream. I don't know. Depends. I didn't think people would even like the workshop development like on stream at all. Like the actual writing of the pedagogical content. But people seem to really enjoy that and get involved in it. So I don't know. Maybe all my assumptions are wrong. So, do you have a Patreon or coffee, or how we can buy you a coffee? I make all of my money through Rust Adventure for our content stuff. So if you have a corporate education budget or something like that, and you have enough space in it to purchase Rust Adventure, that's how you can support me doing this work. All of this goes back into my workshops, my open source work, and my YouTube videos. This is how I power everything. And what comes out of that is I build more workshops, I build more videos, and I build more open source stuff. So that's what we were working on this week. I'm kind of like doing a whole rehash of, or a refresh of the content on Rust Adventure right now. In the sense that I want to have a really solid, like, quick start Rust language introduction that then flows into how do you actually do things. So when we were talking about the videos that we're going to make and ship, these videos about like why Rust, and then like 30 minutes into Rust, and then like the Rust language workshop stuff. This is all kind of like planning that next generation. So a bunch of that content will go on Rust Adventure. I'll release some of it on YouTube, I believe. I haven't decided what's going where yet. But yeah, that's the thing. Technically, I think YouTube will let you do like a one-time, I don't know, are they super chats or something? I don't know what YouTube calls them. I don't know. People did that on the Bevy release video and like requested videos and stuff. So that's cool too. Whatever works for you or doesn't work, it's all good. I just appreciate y'all being here. I also know that not everybody can afford to like support things financially. So I really appreciate people like being in chat and participating and stuff like that, because that is also super helpful. So the question here is, do we implement raycasting, or do we try to rely on Avian? And I think I want to see what it looks like with Avian. We already have all of this code ready to go, so we can always go back to this for a second example. And I think this is a pretty good like introductory ray tracing topic, but I would love to do a treatment of ray tracing when I do that, rather than just dumping it into a second thing. So let's work our way backwards a little bit, and let's drop. The other problem with doing Avian 2D demos is that if you, well, this has to go locally actually. If you do updates to Bevy, Avian is usually a late update. So the Avian examples would all kind of delay by a couple weeks after the release, which is fine. I think it's 0.4 right now, right? Which is fine. It's just something that I keep in mind for any kind of examples or pedagogical content. Like I might, like it puts it into a different category. I can keep everything else up to date with Bevy main. I can't keep Avian-based examples up to date with Bevy main. Avian has to do things so that then downstream consumers can actually use it. And sometimes main works, right? Sometimes the main branch for Avian works. But there's no guarantees there at all. So if we're going to do that, I'm going to pull this browser window back over. I think OBVHS can come too. OBVHS is really interesting. I would love to do like the basic raycasting and then build up into OBVHS. Build CWBVH from tries. CWBH. CW bounding volume hierarchy. What is CW? CW is an 8-way compressed wide BVH8 builder. Each BVH node is compressed, so it only takes up 80 bytes per node. This is like production ready bounding volume hierarchy infrastructure. That's why it's interesting. It's also, I believe, maintained by Griffin. Yeah. And Griffin's somebody who is around in the Bevy community for sure. And then this also provides some raycast. Does this do... $2D, or would we just set 0 for everything? Actually, now that I'm looking at the actual API, if this does raycasting for us and we can use it to rebuild every frame, then we don't have to build the infrastructure ourselves anyway, which is cool. It's a little bit harder to explain because it's just kind of like, oh, you're using this API, but BVH primitives do not need to be triangles. The builder is only concerned with AABBs, with the exception of optional precise triangle AABB splitting. I think we do have triangles, like we have all the triangles, so we could just shove them all in. This is probably a helper for building an icosphere. Yeah. And this is plane. What is plane, actually? Plane triangle mesh with a side length of 2, centered at 0, 0, 0. Not sure BVH would be best for a game real time where everything can move. It would work, but IMO would be slower than AABB check and just check all the faces. That's another thing that we would have to do. I think I have to do all 3 implementations and then compare them against each other. Most of the geometry in our example is static, right? So we don't actually really need, like right now we're rebuilding every frame, but we don't, strictly speaking, need to. We only need to rebuild things that have moved, right? And in our demo, the player is the only thing that is actually moving that casts shadows. All of the level geometry is static. So I think that trade-off actually works for us. Overkill, yes, but the point of using it is not... Like, we're not trying to get the best, simplest solution necessarily. We're trying to take a couple of topics and build examples for them, right? So doing the manual mesh 2D line segment intersection is going to be an example. I think that I'm curious to see what it looks like if you just use Avian, and I'm curious to see what it looks like if you use OBVHS. And both of those are kind of not the original point, if that makes sense. Like, one is, what does this look like to use OBVHS? And the other one is, what does this look like to use Avian APIs? It doesn't necessarily need to be the best ray tracing demo, because the point of those would not be the ray tracing necessarily. It would be the fact that you are using these other APIs that you could then use to do other things in simple scenarios. Titanfall 2 has a talk where they explain their collision system, which is based on a custom BVH of AABBs. Yeah. Yeah, I mean, there's a very common approach, right? Like, give me all the things that I could potentially collide with in this box, and then box those up, and give me all the things I could potentially collide with in those boxes. So I want to... We have all of the vertices here, right? And we don't really need to skip anything at the moment. I think I'm just going to delete some of that code. We do need to, if we're going to do this, have the spatial query, and build the spatial stuff for... Why is after an issue? That's weird. Oh, calculate visibility is an invalid system. Yada, yada, yada. This will give us all of the individual positions. I'm just thinking... If we go to a vertex that's on a shape, can we always ignore the shape that it is for intersections? I don't think we actually can. So the question will be, if we use Avian's implementation and we're raycasting at an angle for a vertex, can we identify that that is the same vertex or not? So we have some code written here. This is technically all of the vertices sorted by angle. So let's just see what we can do here. The shapes, if we're going to do it this way, need to have something, right? They don't necessarily need to be rigid bodies per se. But that does give us some extra information. I think I'm going to go with trimesh. Can we not do trimesh for mesh on... Like collider constructor is probably what it is. I'm so used to working in 3D. Collider constructor. And then we do trimesh. Why is this... We don't get a trimesh from mesh here? Interesting. Hang on. I need to check my avian 2D understanding. Collider constructor. Trimesh. We don't have any from mesh, do we? Interesting. Is that, did that happen to 3D as well? I don't think so. No, we can do this from mesh here, right? It's weird to have from mesh implementations for 3D and not for 2D. It's definitely in Avian 3D. Yeah, I mean, I use it all the time in Avian 3D, right? Especially with Blender stuff, where you're just kind of like, throw a convex decomp or like a trimesh or something like that on something that you're just building. Hey, Hyde, how's it going? Good to see you. I just find it weird that we don't have the from mesh variants for 2D. That seems like a really... Oh, maybe I didn't enable the feature. A component that will automatically generate a collider at runtime using collider try from constructor. Oh, okay. Cool. I thought this was enabled by default, but maybe it's not. This doesn't even have the feature. That's really awkward. Is that supposed to happen? In 2D, there's no triangular mesh but polygons. Just a speculation. Yeah, that's fair. So you think we always need to specify which polygon it's going to be? I guess that generally works because we will have it matched up. It's just a little bit more awkward, right? Like, now we need to manually match up the colliders to the shapes. Which makes it, because I know the circle collider isn't going to be a mesh collider, and we really want the mesh collider, right? Like we want the triangles that we build to be aligned with the vertexes in the mesh 2D. So I think actually, because the circle collider would be just a radius and not a... We will be going straight at all of the vertices anyway. So maybe that's fine. I feel like for projection, that'll cause an issue. I'm developing a scenario in my head where we have the player shooting at the left edge of a circle, and then the bottom left-hand corner of a rectangle interferes with that path. It's an interesting thought. We do have a bunch of segments and we do have triangles, so we could do all of those things. Right? Because the mesh 2Ds for Bevy are all triangles. Right? These meshes all have their triangle lists, which we could get and then add as children. It would be kind of weird to do that. I full screen this. There we go. We could take them and throw them into trimesh. We have all the vertices and stuff. So maybe we just do that. Maybe we actually take the stuff and throw it into the trimesh collider, and we start with that. Which means that I think I want to build this up here. So we have shapes, and shapes is going to be shapes.iter.map shape. I think I'm trying to think about how I want to do this. Automatic way to build convex decomp. I don't know if there is one in 2D. There is convex decomp. We can do convex decomp instead of trimesh. In our case here, it's just going to be rectangles. So let me take this and do convex decomposition, and we need vertices and indices, which means that we need to have our little mesh here. So .mesh.build, these are the, this is the mesh builder trait, and there's one more that I can't remember the name of. So we have the mesh. We can get the attributes. What do we have? I wanted to see attribute vertices, but we don't have that. Yeah, I'm on Mac OS Hide. This is Yabai, so it's not built in. It is Yabai, which I've had a couple of issues with lately, but I think it's because I'm on Mac OS 14 and not 15, and technically I think I have the 15 version installed, something like that. But Yabai on Mac is great. It's absolutely wonderful. Yabai Window Manager, yeah, thank you. Also a bit over, yeah, I don't mind being overkill. I don't mind being overkill, especially if it's like a one-line change. We're going to return the mesh. And the collider. And we'll comment these out for a second. I didn't find the piece of code that I wanted, did I? Where's our mesh 2D iteration? Did I? Oh, it's in lib. I'm not looking at the right file. That would do it. Okay. I was like, I swear I literally wrote this code like yesterday. Why is it not in this file? We'll just panic if something goes wrong. Or like, maybe let me leave like a to-do, I guess. Is my syntax ever correct? No. There we go. Now we get Rust Analyzer. Yeah. I'm aware of that only because of the I'm aware of what Yabai means only because of the project. I didn't know the word before. You started setting up Hyperland on your PC, but it's still bothering? Yeah. Chris is a Linux guy. He just doesn't realize it yet. I mean, I'm a huge fan of Linux in general. I use Mac because I use a lot of graphical applications that tend to just work on Mac that I don't have to like configure and stuff, right? Like Substance Designer or Photoshop, or like I use a bunch of Adobe products. I use a bunch of, like arbitrary whatever. So like having Mac and Windows kind of covers me in all those cases. Linux is still very cool. I like Linux. I've run Linux a couple of different times. I ran Manjaro for a while. Obviously, like Debian on servers and stuff. Yeah. I ran Arch at 1.2, but I do a really bad job of actually keeping things up to date. Okay, so vertices. These are all of our vertices. Right? The vec of those points. This actually has to be collapsed, right? Iter.flatten. What is this supposed to be? Use of undeclared type rigid body. Okay, well, we'll just comment you out for a second. I'm glad you're enjoying it, Karai. Thank you. Appreciate you. So shape here. For iShape and shapes.iter. This is actually not going to be what we think it is. This is going to be shape and collider. And we're going to dump collider in here at some point. And for the meshes, we can do meshes.add here instead and pass the handle back. And then can we do the same thing here? Do we have an attribute for indices? Joint weight, attribute position. I don't think we do. So Bevy, attribute. We'll go for attribute position. I think this is on mesh, but yeah, color, joint index, joint weight, normal position, tangent, UVs. First available custom attribute. Not technically an attribute on the mesh, which is the problem. I guess we could just guess and assume that all of these are triangle lists, which I think they are. But if you build your custom mesh or whatever, then it won't work. Let's do vertices and indices, and we'll do let vertices. And then this will be right, 0 ... length. All right, we don't have this. What else do we have on mesh, actually? I have too many desktops. It's funny that there's a little enable ray tracing field that we can't really use. What else do we have on mesh? Mesh is asset usage and enable ray tracing, and then indices is private. Is there a function called indices that we can call? There is. Perfect. We're going to get that. Your latest Arch install got broken like crazy because you didn't keep it updated correctly. Yeah. Yeah, I mean, I could see that. Why is indices having a field day? Indices, expected VEC U32-2 found indices. VEC U32-2. In indices? Sorry, what? Hang on. Why is this a two-dimensional vector? Oh. That's really weird. Right? So we have to group these into two? I'm used to indice lists just being like a flat list. So we have to iterate over this. But can we do... When we get indices here, do we have the opportunity to get the interior data? It's either U16 or U32. I think maybe he wants to decompose convex polygons, not triangles, hence the 2 and not a 3. Hence the 2 and not a 3. Yeah. Well, the trimesh was also 2, I think. No, the trimesh is 3. Wait, so which two indices do we need then? I think we're going to go with trimesh for now, because trimesh will line up with what Bevy's expectations are, and we can always change it to convex decomp later. Right. I think aligning with Bevy's expectations of what a mesh is probably more useful at the moment. But yeah. If you build a mesh from scratch, the indices are one-dimensional. Yeah, that's what I expected, right? I expected a single-dimensional array of indices. So seeing 2 was confusing. Seeing 3 also would have been confusing. But trimesh using 3 means, hey, here's a triangle. Okay, fine, I can get behind that. Convex decomp using 2 is really interesting because that means you are drawing only the outer lines, I think, is what that implies. If you have triangles, it's probably chunk 3 and then 3 permutations from them. Well, we already have the triangles because of the mesh, right? We have all the vertices. We have the vertices and the indices. Do they describe the data at all? Trimesh. Vector. Right, this is a vec of vec3s. Or vec2s for us, actually. Collision margin is also something that I thought was pretty interesting from the avian implementation, because this would, like a collision margin would implicitly allow us to build a, not a navigation mesh, sorry, a visibility mesh that had margins away from walls, which is really interesting. How much indices must be a multiple of 2 if edges or a multiple of 3 if triangles? Yeah. Yes, that makes sense to me. Yeah, creates a collider shape with a compound shape obtained from the decomp of a given polyline defined by its vertex and index buffers. So this would be each of the vertices in order without the index buffer, and we would create a new index buffer. right? We have the vertices here, vec2. Assuming that this actually works, what is the problem with the collect? Let's fix the collect first. Value of vec2 cannot be billed from iterator over F32. So these need to be collected in a, well, do we need to flatten then? Because this is just coming back as, yeah, so this is coming back as a vec of three-dimensional array. And we need a vec2 actually. So we need to at least map over this. I always find it really hard to type with the inlay hints on. Right, these aren't X and Y, these are 0 and 1 because we're working with an array. Come on, VS Code. And they're array indices. What am I doing? Cool, so this is going to be a vec2 of those vertices for every shape. This only happens once, so not worried about it. And then indices is every point enumerated, windowed with the last pair cycling around, right? So this is like vertices dot iter. Actually, can we do windows right here? Let's see. Well, length equals vertices dot length. Right. So we have the U size. We want to enumerate first. So iter, enumerate, cycle, take, or not take, right? Do we want to take yet? I think take is fine. Take length. Is it length plus 1? If we have a set of 3 points and we cycle over them in windows, then we need 4 items, even though the length is 3. So we're going to take that number. We are going to use iter tools because iter tools has tuple support. Tuple windows. We're going to map over the tuple windows as, I guess, A and B. And we are going to take the U sizes. So this is going to be vec2 A.0, B.0, right? And this will give us a line across all of the vertices in order, which should be counterclockwise. Could you just steal the tri-mesh from mesh code from Avian 3D? Maybe. I think that it would add more complexity, but we can take a look. The other thing is that the crates are actually common. So avian is actually this great at the root. And do we have, maybe it's in collision, collider constructor somewhere, tri-mesh builder. I think the convex decomposition might be more difficult. Also, for 3D, this actually doesn't need to happen. Right? Like for 3D, we already have the from mesh implementations. Tri-mesh builder, collider transform, collider hierarchy, that's the plugin. Constructor, is this collider constructor? Convex decomposition, tri-mesh. So let's just search for from mesh. Find the processing for it. Because the definitions are separated from the processing a little bit. So here's where it goes into the parry calculation, because really the avian implementation is based on the parry implementation, and that's why there are differences. Okay, collider from mesh. Where's our convex decomposition? This is for the 3D stuff, because this isn't enabled on 2D. Tri-mesh from mesh. So there's extract mesh vertices indices, map over the vertices indices, shared shape, convex decomposition. So it's just passing them in. So really this function would be the interesting one. So we get a mesh, we grab the attribute like we're doing, we grab the indices, although we're kind of just like fudging our indices right now. I think we have to do our little fudging of indices because do we? No, we don't. Maybe we do, actually. The indices for a mesh 2D is going to be pointers to the triangles, right? So we don't want the triangles actually. Yada yada. Chunks 3, iter, map, collect. Indices U16, indices U32, chunks exact, map. Does chunks exact give you the wraparound? No. So I think we're doing something slightly different. And I think we have to. Why is that red? Is a question. This also doesn't help the example in that sense, right? Like it doesn't help to have to do this like manual decomposition anyway. It doesn't make it simpler. I think these have to be U32s, so I'm going to cast them. This is not a Vec2. This is a... Wait, what does the index have to actually be? vec of U32.2. Trimesh indices, we have to collect this. We have to specify what this is supposed to be. It's not that, it's this. Did I mess something else up? Expected an array with size of 3, found one with size of 2. Oh, right, because we switched to trimesh. And then I switched back to convex. Value of U32.2 cannot be built from item unit, which is my fault because I put a semicolon over there. But in 3D, all the faces are on the boundary surface. In 2D, all the edges are not always part of the boundary polygon. This might confuse things. You don't know avian enough. Yeah. Yeah. I think that this might not work out. What we're doing here is basically just investigating what it would look like if we were going to build things like this. This doesn't mean that this will be the way that everything works, right? Like, we're not necessarily going to use this as the example. That's the physics debug plugin. Physics plugins. Prelude star. Right? Like, one of the reasons it takes me so long to build examples is because I end up building them like 3 times. And I do things like this because instead of making assumptions about what it would look like if we did this with Avian or if we did this with OBVHS or if we did this manually, I actually just build all 3 of them out and I look at the output and I go, is this going to be an understandable way to present this or not? And then I pick approaches based on that. Encountered a panic in what? Where did we panic? A min comp less than equals B max all. In Collider. What is the issue here? This doesn't actually collision collider mod 510. Collision collider mod 510. Collision collider mod 510. So this? That doesn't look right. It's got to be 512. Let me get on the release tag. Important if you're going to do like tracking back and forth between an error message location and the Git repo that you're using the right branch. So this is the V4 release branch. Increases the size of the bounding volume in each direction by the given amount. So these must be equal there then, right? It would be nice if this debug assert actually outputted any actual information about the error that actually happened. let's assume that we did something wrong with the calculation here. And let's take the indices. Oh, but I wanted you to do the whole thing. Dang. That's unfortunate. Let's just assume. Right, and then this is indices, and indices can be one or the other. U16 and vec of U32s. Vec of U32s is items.iter.map vec.x. Or actually, we have a function for that, right? Vec.as array to array. Oh, we're mapping over in each individual one. We need to Windows this, unfortunately. And we need this to be an array, right? X, Y, Z. And this is let indices, which is a vec of array of U32 3 equal the match. And if I don't forget my syntax, then things should work out. Value of type vec of U32 3 cannot be built from references. So done. Could also just do dot copied, but same issue. Okay. So at this point, basically what I would do is there's something that I don't understand about the translation from a mesh 2D to an avian parry mesh. We could either investigate that code more deeply, or we can look at this and say, if I was going to tell somebody to do this in an example, would they be able to without developing that deep understanding that I would have to go grab right now? And I think the answer is no. I think the answer to this is the avian version of this example doesn't work because you have to manually construct all these colliders. If it was doing that for you, the level of this example comes way down, right? But because you have to construct the collider meshes yourself, you then have to make a decision between things like trimesh and convex decomp and other things. And that means you have to have knowledge about all of the possible 2D shapes that can get created, which ones you're going to code support for, and then how to actually construct the result. And I think that that is off the path. I think that's too far off of the path. So for the benefits that the shape casting or the ray casting from avian would get us, I think we lose the understanding of, hey, these are just a bunch of points on the page. So I think that for me solidifies that this is a bad choice for the example. This is not going to be the way that we're going to do this. Does chat agree? How do y'all feel about that? This might confuse things. Yeah. I think that the possibility that Avian could have saved us some raycasting really gets taken away when you have to manually build the colliders. If we're manually building the colliders, then manually doing the raycasting is not that much different. And if you manually do the raycast, then you work with the actual vertices and meshes. So if something goes wrong, you have the direct access to what is actually there. Whereas this error specifically, the one we just ran into, where it's like, you tried to construct a mesh, you tried to pass it to Parry through Avian. Do you even know Parry exists as a thing? Et cetera, et cetera. Like, you fall down a deep well of how do you actually debug what this means? And one thing that I've noticed is that a lot of people don't have the, oh man, what do I call this? They don't have the built up pattern of, hey, I saw this, I read the error message, it's at line 510, column 9, it's in, the source collision collider mod file. I'm going to go to the Avian repo. I'm going to make sure I'm on the right branch. I'm going to go to that file and check that line. And then work backwards from that function to figure out where it's being called when my convex decomp is actually getting built. Like, that is a lot of process that I find a lot of people are missing the capability of doing on their own. And it's also not something you should cause somebody to do in the example. So this is also where I was doing, we did a temporary, we did a PR yesterday. So Jan built the PR, but we were in off topic talking about log components and how to get better information out of log components. And this is where I was doing any of my experimentation for that. I think log components is going to get some nicer output for 0.18, which is really cool. So I think I'm just going to check out lib and that'll revert us back to our original. We are not going to use Avian. Avian doesn't give us enough in terms of benefit for the cost that it's going to take out of the example. So next question is, I'm going to take my format layer and copy it, and then also check this file out. I think I'm going to include this format layer moving forward in my demos. We'll see though. Yada yada. Cool. We run this, make sure it runs. Cool. So the thing that this format layer is doing is giving a pretty print to any debug information. Yeah, you agree. A lot of people don't have that pattern in their toolkit, but they should. Yes. But they definitely should. I don't know how to give people that information. I don't know how to give people the the capacity to go in the direction that we just talked about, go from error message to source code to function to back up the chain, other than showing it on stream like this. That's the only way that I've seen connect with people, when they literally see somebody doing it live. It's very hard to write pre-written content to cause somebody to do that, because if they don't have the inclination to do that in the first place for their debug process, then they will never choose to do that because they don't know to do that. But if they see it like on a live stream or something like this live stream, right? Then people are like, oh yeah, well, I can just go check the code because I saw Chris go check the code last Saturday. Yeah, brute force, simple line intersection check function inside very hot loops. Yeah, that's where we're going to start. We're going to start with just a very manual. I'm probably going to comment out a bunch of this code, not the code in this spot, but the code in the lib. And we're not even really going to do this iteration here. We're not going to build our mesh just yet, which means that all of this also gets commented. And we're left with, we have the positions of the vertices for all positions, right? They are also sorted by angle to player, which is cool. And now from here, we're going to want visualization, right? So we'll grab this and put that here. This is, we have to get this to work somehow, is the thing. Let's start with just drawing to every vertex that we're going to hit. And for visibility data, this is going to be player position to visibility data dot global position. So this should draw lines to all of the vertices. Right? This is everything we are going to look at. All four of the corners for all four of the boxes. And if we move our little player around, you can see the web of rays that we're going to have to cast. This is probably a useful visualization at some point. Let me actually just take a couple screenshots here. Because at some point this becomes a video, and if I don't have if I don't have the screenshots, then I won't be able to show this unless I rebuild it. That's one of the things. I should start recording actually the streams. And then be able to use those for video content. Okay, so we have all of the vertices that we're going to have to do. For each vertex, raycast against all other walls, right? So really, this is going to be like vertex iterator inside a vertex iterator. We don't need them to be sorted, so we could just go for all positions again. I'm just thinking here. Is it better to clone the iterator that we already have? Right, base iterator. And then in here, for every time we do this, we're going to do right, and we still have this iterator. So other vertices. We don't need other vertices though. We need all other lines is what we really need, right? So is this even correct? We need to iterate over each mesh, draw lines between them. Random question. Should I prefer bundles or required components for big chunks of components? I think that the general move is to require components, but bundles are not wrong, right? The trade-offs of bundles versus required components are basically for bundles, you get to do a couple of things like create a number of different constructors for a set of bundles, etc. Downsides of bundles as like a primary interface is you don't get to choose very much. You kind of have to fill out everything every time. Required components don't have the ability to access from world implementations for the required components. So if you're trying to set additional data in those dependent components, you can't do that until BSN lens. So really the answer is start with required components unless you find that they don't fit your problem. And also, you don't always need to put required components on everything, right? If you have a single spawn, right? If you have like this is a single spawn, right? I don't need to create the player component with the mesh 2D, mesh material 2D, transform, and children like required components, right? I can just spawn this. This only gets spawned once. If this was going to get reused, I might put it in a function that returns impl bundle rather than a required component stack. Required component stacks are kind of like for this component doesn't functionally work without these other components being there. So if you insert it, we have to insert those. But like a function that returns impl bundle is also very valid. So a third option between bundles, required components, and returning impl bundle. I think in the future, there will be a difference between required components on specific components and templates or scenes. And the difference there will basically be like, if you have a single component API that you can insert and will activate all of the functionality, that is a required components kind of territory. If you have anything hierarchy related or nested or anything more complicated than that, then it's going to be BSN. And it's going to be a function that returns impl scene effectively. Anyway, in the abstract, none of the choices are wrong, right? Like, should you prefer one or the other? Probably prefer required components over bundles, but you can also do like a function that returns impl bundle. If you have any sort of hierarchy, you have to do that, actually. You can't do hierarchy in required components. So, yeah. You would keep it sorted. It will still improve the general algorithm and introduce to this CCW optimization. You think? I think the CCW optimization goes away, right? I think that because we want to put the rectangle around the whole thing, if you're like in a room or something, I think we have to account for both of those. So I think we get rid of the counterclockwise optimization. Just drop it entirely. I don't think it'll work. Where are we? Lib. Visibility data. We've got other vertices. So the thing that I was thinking of is we have to build the walls, right? Because what we're effectively going to have is a ton of line segments that we are going to raycast against. So yes, we can leave it sorted in a sense, right? But I don't think it'll matter at the current time because we're going to have to touch them all anyway. Yes, this bounding collider, which are inside, would need special treatment. Yes. Right now, we're not inside of that rectangle. We are inside of 4 lines that I drew as a rectangle. Right? This is just 4 lines. But that's not good. Like, that's not a good solution, right? Also, if you draw the line in the opposite direction, you end up with the same problem. So it doesn't even work for that. The angle is important, I think, for the initial, like, the algorithm here is going to be, we sort all of the vertices in the entire scene by angle, right? So we start like west and we sort them clockwise until we get back to west. That kicks off our algorithm. We're going to iterate over all those vertices with those individual raycasts. The next step is we have to, for each vertex, decide whether we have to raycast past it or not somehow. Right? So I think we actually have to do a raycast here. We have to get the direction of our ray. We have to get the I'm 50-50 on whether this is going to result in corners. So we're going to have to figure out this. The corners here, you can see the issue between the bottom left and the bottom right. So bottom left here, if we raycast to this and it hits that point, then that will mean that we have to decide to get the second hit. If it hits this point, we will have to decide to not hit the second hit. So I think there's something along the lines of like, I don't know. It'll be interesting. IMO, simple marker component, bounding polygon, and reverse the indices for meshes that have this component would be easy to understand, but a limitation of the final product. Yes. I would love to not limit the final product like that, because I think the demo that I want to build is like a couple of different rooms that you can walk around, and then we do the texture for the lighting and maybe have some guards in each of those rooms. At which point you would be moving across the boundary of 2 bounding polygons. And thus you would be inside of one and outside of another. I don't know. I'm thinking about the raycasting here and thinking if we go to this point, right? Do we hit an intersection on the horizontal and on the vertical here? Basically, we probably get rid of those 2. When we're doing the calculation, I think we get rid of adjacent walls. But then the question is, how do you, after raycasting this direction, determine that you shouldn't hit this wall and you should hit this wall? All right, because we're going to end up with a list of hits and distances. And I guess we just code it out and see what happens and then make our decision. Which means I need to figure out how to do this because my math is all homegrown. So I need to figure out what the way to intersect a ray with a line is. Which I think vaguely is like 2D cross product intersection. But these aren't vector equations, right? And they're not full lines, so they're line segments. By checking if we hit the backside of the edge, but once again, what about edge inside the mesh? The rectangles, diagonals? Yeah. Will we hit the diagonals? We will. I think for 2D, we will only hit the diagonals if they're defined as being interior, which I don't think they ever are for 2D. So I don't think we'll ever hit that interior because the triangles are defined by the outer vertices. No, that's going to be incorrect. Okay. In any case, this person says, yeah, checking if the intersection is bounded. Okay, so 2 lines and then we do a bounds check. The question is, what is the actual math here? They're doing intersect lines with start of 1, end of 1, start of 2, end of 2. Append it to be 3D. Cross product itself with the other one for itself. And then kx over k is the only part here that I don't understand. Because if we cross product the line, we get basically a line pointing out of the screen, right? And then if we cross that again, we should get the new line. Also, when ray casting to a vertex position, yes, both edges will create a collision. Also, this will happen if the ray paths exactly or very close to another vert position. Yes. This always complicates simple 2D raycast, even just for text rendering. Yeah, it makes sense. So they think cross product. I think we have. So the question that I have right now is having mostly done raycasting in shaders and not in a 2D environment like that. Mostly with SDFs. So ray marching is really what I'm more familiar with. There's a function in GLAM for vec2s. It's like perp dot. Wait, is it not? Wait, perp dot isn't what I was thinking of, is it? Yeah, 2D cross product. So I wonder if this could help us at all. Everybody that I've seen seems to be doing the 3D version. So let's see. If we were going to use the code that we just saw, this would be like fn intersect vec2 vec2 vec2. Right, start, end, return. Their approach is effectively MP append P1 for oh, this is silly. That's why. Because I'm thinking of this as it's actually this. Right. We have lines. So we don't need these to be vec2s per se. Or vecs or whatever. These are just tuples of vec2s. And we're going to return a vec2. So basically this for start and end. Wait, that doesn't why did I call these start and end? Yeah, start and end need renaming are to be plurals. Let me intersect lines S1, E1, S2, E2 are they don't have any types in their code and they don't specify what these are. So I'm assuming that each of these are an individual point on a line. So this is the start point, end point, start point, end point. So we could do this. We'll call this line 1 and line 2. Right. We could call these segment or something too. So we end up with line 1 3D and line 2 3D. So we have start and end. We could also make our own. Wait, Glam doesn't have anything for this, right? Just before I get too far into this. Affine, quat, mat, vec. Nope. Basics only. I don't think it matters, right? Well, I mean, like we can use one. Because the Z's are all going to be the same. I guess they use one in their algorithm, so let's keep it with one. Solve, just cross product everything. We're just going to do line 1 cross. Wait a second. Yeah, line 1 dot cross, line 1 3D dot 1. Cool. And then this is going to be the same thing for the other one. which ends up with their little Ks for line 1. Let these names are terrible. Right. So we end up with a vec3, and then they want to return this as a vec2. So does this work? I actually don't have any idea. This is just code that I looked at. It looks vaguely right. I don't know. We're going to find out. In practice, you try to keep 1 for position, 0 for direction, even when not required. Yeah, fair. So given a line and a line, we should be able to find the intersection. We aren't doing a bounds check here, so let's leave a note of like to do bounds check, right? Make sure that the thing that we see is actually in that spot. Let's do vertex iterator, right? But take 1. So we'll only get the single situation here. And then we're going to intersect a bunch of stuff. So for other vertices, or for other in other vertices, if I can type, this is going to be visibility data. So this is going to be, we have player position here, right? Yeah, player position. And this is going to be a vec2. So we have player position as our base, and the direction to the next point as our ray, right? So or the direction to the vertex, actually. So is this just the vertex in our situation? Player to vertex? And then our second position is going to be vertex to vertex for these other vertices. These other vertices have to be tuple windowed, but ideally they are tuple windowed only inside of the same mesh, because you can only draw a wall between 2 vertices of the same mesh. So this is taking a vertex iterator, but I think we actually want to deal with this instead. I think we want all positions here. So I'm just going to do this inefficiently to start with, and we're just going to take all positions and we'll iter. And this gives us a vec of visibilities. So this is for each mesh in here. For each mesh, make all walls, right? We will have all the global positions. So really all we need to do is, in order, cycle with the last one like we were doing before. So Let's call these mesh vertices. And we'll do mesh vertices dot. Is there a better iter tools function for this? Is something that I am thinking of as we go through this. Like an iter tools function for all combinations of sequential pairs of two, including the end, so that I don't have to like cycle and then increase the length by one. Combinations of elements is not what we want. Cartesian product is not what we want, because we don't want interior triangles anyway. Circular tuple windows. Return an iterator over all windows, wrapping back to the first elements when the window would otherwise exceed the length of the iterator, producing tuples of up to a specific size. So this is not infinite, but I think it is what we need. Right, so we do circular tuple windows. Map. And then this is 2, right? So A and B. Did I not bring iter tools in? I didn't bring iter tools in. Come on, iter tools. Is it not going to give me a code action because I have a syntax error somewhere else? Okay, we're going to manually... Oh, we already have iter tools here. What is the problem? Oh, because I didn't iter. So we've got the visibility data for both of these points. These are the global positions, right? So A dot global position, B dot global position. And this is just our point, right? So vec2, this is our line actually, sorry. So we're going to return this tuple. And we're going to make this flat map. And we're going to collect, do we need to collect this? I think we're just iterating over all of them, right? So we can then do this loop up here. Right, so we've got that line. We're going to pull up our intersect function. Throw it in here. This is going to be other. Hopefully Rust Analyzer will help me out by formatting my code in a second, even though I'm doing a horrible job of keeping it formatted. So this theoretically should be the intersection point. Which, if we take that and we say player position to intersection point, intersection point, intersection, what is going on here? These are the same. This is not what I need, is it? It's a tuple and I need it to be a vec2. Wait, it is a vec2, right? Yeah, it's a vec2. What be going on here? Available in a different binding in the same function. Thank you, compiler. Putting it outside of my loop is definitely an issue. Okay, so I think we're only taking the initial one, right? So here's our line now. So if we get rid of our take one here, we should see a bunch of full length lines then. right? These are literally all of our lines. They are not line segments. They are just all of the lines for all of the vertices for all of the positions that we could be raycasting against. Realistically, we only want one section of this, so probably line 2D is the wrong thing to use for the gizmo, right? Can we do a line segment here? Did we call that a line strip? Line strip, draw a line in 3D. Line strip 2D, draw line strip 2D. And this is... Why is that a 3-dimensional vec2? Draw a line in 2D made up of straight segments between the points. And it has a vec2 0, a vec2 x, and a vec2 y. Let me just grab this. If VS Code will ever let me use my editor. So this is the demo of line strip 2D. This is a 1-dimensional, so we probably need to like... Do we pass in the end of... Wait, this is so strange. I'm gonna have to read the docs on this. This feels very strange. Because, oh, it's 2. Okay. I get it. I get it now. You don't have to. It can be any slice. There we go. Any slice. So in our case, it's this. Which is still all of our lines. Can I squeeze this down? There's definitely ends here. But they're in the wrong spot. Right? Right. So this isn't giving... Well, let me do this instead. Let me, instead of line strip, let me visualize the intersection point. And this is going to be intersection point. Just to make sure that we're actually getting the things that we expect to get. That's interesting. That feels like a lot of intersections that aren't actually intersections. Hey Cameron, how are you? Thanks for coming to stream. How's your day going? Right, here's all of our alleged intersection points. If we... Where's our vertex iterator? I'm going to add our take 1 back here. So we're only dealing with one. line. So here's our line. And this is the extension because we're not checking for bounds on anything. We have to check for bounds on everything, right? So that's what's happening here. We have the line, right? We have the point that we're hitting. We want this point over here. But what we're getting is the vertical extension of all of these box walls. So we got to do our bounds checks. So when given an intersection point, we have to check to see if this intersection point is greater than, less than, greater than, less than on X and Y. Can Glam help us here, or do we have to write this out in a painstakingly manual way? Probably can't help us here, right? Because Glam doesn't have any concept of multiple. Is there any comparison that we can do that makes it easier? Because it has a couple of fun comparisons. We don't want like min or max, right? But we can return the mask. And if we do these masks correctly, we can combine the masks, right? So I don't think we can actually do that without doing more stuff. So let's do, we are getting our intersection with this other point, right? This other line. This other line is the one that has to have our things. So other dot 0.x dot min other dot 1 dot x, right? And if we write this in the painfully manual way that I'm about to do this, then this will become the x min, y max, x max, y max, beta max, HD DVD. Anybody? Okay. So we have x min, x max, y max, and intersection point has to be inside of these. So both of them have to be lower than both of the x mins, and both of them have to be lower than both of the y mins. So we could build a vec2 and do some fancier comparisons, but we'll do the equals, less than equals, greater than equals. HGTVT was a wild throwback. That's what I'm here for. The 2003 disk technology throwbacks. Okay, so if we run this again, we should be filtering out for the right points. So we are now correctly getting only the things that are actually in the spaces that we want them. We also have to correct our direction like Xavier correctly identified earlier. Also, there might be a way to do the intersection in a way that makes this easier, quicker. Absolutely. I would say personally that while I can go figure out the math, it will take me a second to go look it up, is kind of what's going on here. Math, my math education is almost all like self-driven at this point. So all of my linear algebra knowledge is just like what I've happened to use and what I wanted to go look up to actually use for, you know, building a ray marcher or something like that. So I wish I had gotten more math education at some point, but I'm building it up. Gizmo circle 2D. So this intersection point also has to be in the right direction. Can we do direction by testing for slope? Like the directions have to be the same, right? So the direction for this and the direction for other have to be the same. No, the direction for this and direction for player position intersection point. So we'll do vec2. These are vec2s already, right? What am I doing here? I need to subtract them. So this is going to subtract player position from global position. And this is going to subtract player position from intersection point. And these should give us the directions of both of them. So we should end up with 3 debugs, roughly. Obviously, this is running every frame, so we don't just get 3 debugs. But all of these look the same to me, and that doesn't make sense. I guess all of them are on the slope. So the direction on the slope. Oh, because okay, so the global position of the vertex minus the player position, we actually need this to be the opposite direction, right? Because we're trying to go from 0 to the position. And then yeah, then we get differences. So the question here is, we know they're going to be the same values, so we don't need to like compare them, right? We do signum on both of these. And hopefully get 1 and -1. And then go from signum to comparing them. For, I think, equality, right? So if they are not the same, we don't want to render it. Oh, if they the opposite. I think I moved the math around there a little bit. So we're doing player minus visibility and intersection minus player. I want to just check the visualized output of this as well. I think this is going to do either everything or nothing. No. I think this is the way that I want to do the math. Keep the calculations the same, right? Position minus player, or player minus position, or whatever it is, and then set the equality rather than trying to like flip the order of operations. It would be nice to have a name for these, but I can't think of a thing to call them, if I'm being honest. Pause minus player works better for you? Yeah. Well, I wanted it to be the difference minus the same for both of them. That's the thing that I cared about. Having player in the same position for both of them was the thing that I cared about. Player to hit. I guess it's really hit to player, right? If we do it like this. Player to vertex. And player to hit. Because we're recentering it around the origin of the player is what we're doing here, right? From a geometric perspective. So I guess still doesn't really describe it all that well. This format here still doesn't describe it all that well. Like, really what's happening here is we're recentering the origin for each of them to give us the vectors. Yeah, those names make sense without the normalize and signum. Yeah. I don't know what to call the signum. Because it's like... It's like the direction of the slope. Also, somewhat interested in what happens with this calculation if we're horizontal, if that's pathological or not, but we'll figure that out. I think it still works out because you still get a subtract or a positive or a negative on either side. So these are our hits. And we can do this for more than just the one vertex. So we have little dots on all of these places. And this is giving us all of the intersections. So I believe that this line right here, for example, is this vertex going through the wall, which is cool. Can I draw the lines again? There we go. Those are the right lines, right? Gradient? Is it the gradient? I'll have to stew on that one. I gradient feels directionally accurate, right? Because if you were going to take the gradient sample in a shader, you would take the 2 points and do the diff. And I think I like gradient. I think I'm gonna use gradient, even if it's not perfectly accurate. The normalize will break if the player is exactly the same position as the vertex or hit. I think that's okay. We'll figure out if that's okay or not, but I think for the moment that's okay. Let's grab more of these tailwind colors. I almost feel like I need a prelude that brings in the tailwind colors. Okay, so this is good. We are now iterating over all of these. We have the hit locations. Let's make some of these circles a little bit bigger. It's probably pretty hard to see those on stream, yeah? So we have all of our locations with all the circles that are the hit points. We are iterating in clockwise angle-based order, starting west. We now have I think some questions to answer. Really, how do we determine if we're moving into a shape is really the question here. Because we hit for all the vertices that we have, right? And because we hit for all the vertices we have to determine whether to extend or not. I think we need both, actually. Right? I think that the triangle that's here, this like bottom left triangle, needs to go to the edge wall. But the triangle that is from bottom left to bottom right of the rectangle needs both of these points instead. So I think do we need to store these as we go around in a circle? any vertex we hit is valid unless the next vertex is off mesh, which is the same kind of thing I was thinking about last time. I want to get away from that specialty logic though. So really what these need is the prior vertex hit. We need both of them, right? And we need to skip some of these interior vertices, which we were successfully able to do with the mesh order skip, is what I'll call it. Once we get to the top right corner, though, right? Because we end up doing the triangle, like this really thin triangle right here. That's bottom left, bottom right. Then we go bottom right to top right using our little... Using what? Do we just build the extra triangle there? Do you just commit to building the extra triangle? We just hit here when we're going for that vertex, so we build a triangle. Yeah, which will bring that... I'm trying to avoid bringing back the counterclockwise inversion. Do we just commit to building the extra triangles? At which point we basically, for every hit that is nearest, build the triangle. And then when we look back, if the previous raycast has a hit on our line, then we use that instead. As long as there's only the actual vertex that we hit before it. Right? Does that work? I think that works. If we have a hit to a vertex, like we store each of the raycasts for the next processing. What if the rectangle is thin? What if the rectangle is thin? I mean, like vertically thin? We could just place a rectangle in here. Do you have a suspicion about a thin rectangle? Is that why you're saying that? Let's see. Let's go 1 pixel wide triangle that is 100 tall. And let's put it like somewhere in the middle. I forgot I did negative sizes of these. That's really funny though. Let's get rid of the negative sizes. Negative sizes don't really make sense anyway. So this is our thin rectangle. And what we end up with is 2 hits per edge. I think we just saw that issue show up right here, actually. I think a small enough rectangle where it's like smaller than the epsilon might be an issue. You know? But I don't think we're at numerical accuracy just yet. Unless this is that issue. I like how the circle is like pointing out, hey, look, there's a big fuck up here. Why does it stop? Because why? Why does that ray stop? And it consistently stops, or it just stops in certain situations? It looks like it might actually be messing with it. Let's see, can we? I can't get it to actually stick on. I think on one hand, numerical accuracy issues are probably not something I'm going to worry about at the particular moment. There we go. No, stay. There we go. I'm going to go with, because that is behaving like that, that this is potentially. It feels weird. I don't think we're doing any logic that stops that, are we? I could zoom in way and get a higher resolution on that. Are we doing any logic that stops there? Right, we've got our bounds check and whatnot. Oh, if k is not equal 0, otherwise none is what our so this actually has to be an option. That is not the right way to do that comparison. It's probably 0 with the epsilon, but return none. There's a way to do that comparison with the epsilon, right? Mantissa, epsilon, infinity. Again, this is where my math fails me a little bit. I don't have to just do like plus epsilon and like greater than less than, right? There's going to be a function here to check within epsilon. No, you're good. You're good. I do think that if I won, so I could just leave it at 0, right? I could just do this and be like, oh yes, it's 0. And then we have to fix some stuff up here because some of these are not going to be valid anymore. So this is intersection point, right? This could be none. like intersection return none, and we'll include the visibility data here. I don't know if I put debug on this actually. Yeah. Where did I define the visibility data? Oh, I have nothing on visibility data. That's right. I really just wasn't printing out those values, was I? Okay, so we don't see the issue currently. Does it pop up when this happens? No. I just saw it happen on the rectangle. There we go. Rectangle over here on the right. Hopefully this doesn't break it. This. Why does that stop? Which line is this? This is the line for this vertex. Are we just stopping at the first impact? Is this a situation where we're technically missing that vertex, right? There's no circle around it. So we've kind of missed the corner. Thus, we've hit here. Something to dig into for sure. 001, you think? I'll just... There's definitely something going on here. And it's definitely good that you pointed it out. That's less than. I just thought I was going to be able to find a function that like had the epsilon already set up to do this comparison. But maybe that doesn't actually exist. There we go. That's an issue, right? That is a problem. Let me see. Is that due to the way that we're filtering? Because we're only drawing for some of them. So let's get rid of our filter here entirely and see if it still happens. So this is just for everything, right? And this looks stable as all hell. So it's entirely inside of that comparison function. Or that comparison. Because this, it never happens. Right? So the issue isn't in the math. The issue is in the if condition entirely. Y'all didn't see it doing it, right? I didn't like just miss it because I was looking at chat or something. I know it's a little bit harder to see with all of the stuff going on, but here is literally every ray we're casting. The way that we are trimming these is first, we're checking to see if they are inside of the bounds of the things that we're trying to hit. So this should cut out a lot of the inaccuracy around like a plane extending past its. And that is the issue right there. Actually, it's the bounds checking on it being on the line. So it's this for some reason. Epsilon is okay, or 1e -6, but you need to add abs if it can be negative. Yeah. Let's minus. And plus. And that stabilizes it. Nope. There's one. I feel like that's particularly interesting. Let me do a. I could do like a spacebar turn on, turn off for this, but is the bounds checking here even accurate? So the X-min is other, right? So it's the thing that we're intersecting with. XXYY, XXYY. There's probably a point between the streaming software plus live plus video compression pipeline where we would see less lines than you and anti-aliasing somewhere in the middle. Everybody in chat that has said there is disappearing lines is accurate. It would be cool. I don't think I can thicken the lines. Unfortunately, I think this is all we get for gizmos. But if I set this up correctly, it will happen. There. Right here on the top left of the cyan rectangle, there is a line that comes out of the player and goes into the top left corner and then stops. And that only happens if I'm doing my bounds check. Oh, you see it happening on the thin rectangle over here on the left-hand side too. But why does it stop? Even if the intersection is calculated to not be on the segment, it should continue either way. I'll get back to that in a second. Somebody has a question. A little off topic. Can you tell me what the best editor for Bevy is currently? Something more user-friendly like Unity or Godot editor. You have... What kinds of games are you building? 2D, 3D? Are you 2D or are you 3D? Because that will be the differentiating. They're all external editors, right? And they're all external editors for programs that already exist. If you're doing 2D, things that people really like are LGTK, which is by the Dead Cells people. or tiled. My preference is LDTK unless I need a feature from tiled. So if I'm not doing isometric 2D, then I'm using LDTK in general. For 3D, you can either have, well, there's more options, but there's Trench Broom, which has it in it. Wow, that's a bright page. I wish they didn't use white as the background. There's Trench Broom, which is a very like Quake binary space partition style brushes 3D editing environment. And there's Blender. Cloudflare is going to tell me I'm a robot. And there's Blender, which is, you know, you probably know what Blender is, right? If you're going to use Blender, I wrote this integration so you can place components inside of Blender. It's called Skeen. It's the name of the domain is bevyskein.dev. You can find it in the Bevy Discord. There's a channel for it if you have any questions. This is what I use. Other people like the workflow that Trench Room gives you. It's significantly more restrictive than Blender. But some people like it. All those are not an editor, just a... Did you mean to... I think you tagged the wrong person there. You can programming inside that editor, Blender. No, you would use VS Code or your text editor of choice to write Bevy code. Like whatever text editor you normally use for programming, that's the editor that you're going to use for text. For 3D assets, you're going to use things like Blender and Trench Broom. Why is it stopping? It's stopping because we're not drawing the gizmo. We don't draw the gizmo because the intersection point should be checking these bounds, and apparently the bounds are wrong in some way. Right, like if I bump up the margin on this to 1, we probably don't get these issues ever. Right? Like super stable now. And basically all we've said is a collision point counts if it's within 1 pixel. And there's no issues now, right? So I think it's just that the numerical precision of doing these bounds checks on the edges can go one way or another depending on how the calculation for the F32 fell out. There's also Bevy tools for better F32 stuff. These are not what I'm looking for. Structs, affines, constructors, float extension, lerp, inverse lerp remap, fract GL. It's not really what I'm looking for. I thought Bevy somewhere has F32 extensions. For doing this kind of math in a better way. But I'm not sure exactly where it is. And I don't think I'm going to look for it right now. I think calling the bounds check, we'll call this like arbitrary margin, right? And as long as I call this arbitrary margin, in this example, people will be like, oh, this is just like a margin around the area at which you could be checking for the bounds hit. I think 1 pixel is fine. Like the space of 1 bias, you think bias? Should I call it margin bias? Margin bias. Make it clear that it's like a bias about like how exact you need to be if you're greater than or equal to. And I think 1 pixel is fine. 1 pixel off. Whereas before we were like trying to use epsilon, which is like way smaller than a pixel. I think this is fine. And then we re-enable our other test and make sure that that doesn't break anything either. I don't see any flashing. I think this is good. So now we are at the point where we have all of our raycasts and we just need to build our triangles. The obvious answer to start with would be take all of the nearest positions from angle order and build triangles out of them. You're talking about epsilon for the other code, the one that decides if there's an intersection or if the two are parallel. Oh yeah, we don't do the parallel to. Oh, I guess technically, but. What was the recommendation you were making? Abs cross Z. Oh, yeah. That's how people usually do it, right? I don't know why that doesn't stick in my head. I always end up doing this like extended if expression or if test instead of writing abs and checking. And I don't know, it just doesn't stick in my head. Cool. So we've got all of our raycasts doing everything that we needed to do. The code for the raycasts is fairly compressed, which is fine. I think this is significantly better than the situation that we got ourselves into if we were trying to use Avian's raycasts, because building up those mesh vertices required even more code than we're just looking at here. So we could naively build a triangle for every nearest vertex, right? Can we build a triangle for the deeper triangles as well? We have all the hit data. We can basically go from a current hit to both hits on either side of it. We go from the current hit to the previous hit, or I guess current hit to next hit. Current hit to next hit probably takes, or prioritizes the hit that is on the same line. Right? So if we're going from bottom right to this raycast, I guess, is the next one. Then we make a triangle with this first item, right? That's how we choose our positioning. If there's one on our line, then we use it. If there isn't one on our line, then I think we've done something wrong, maybe. Let's see. There's always going to be one on our line, I think. So we go through everything. We go for every vertex. For every vertex, we go to the next raycast, right? Or the next vertex. Well, the next raycast, we'll say. So we go to the next raycast, and then we have to know which directions this could go in, I guess. Trying to think of the algorithm here. We have, right? Like if we're bottom left, we have this vertex, we have our raycast, right? So our first triangle line is to this vertex, no matter what. We move to the next angle sorted raycast. The next angle sorted raycast requires us to choose between 3 hits. In this case, the shortest hit is the right answer, right? Will it always be? I think so, because this is a visibility algorithm. So the question then is, what do we do for this case on the right-hand side here? Somehow we get to this raycast as our base. And how do we determine that we need to start at the further hit? Because we've already drawn the triangle to that line. I don't know. Open question. I feel like I need to work through this on paper to try to get this to work out. Just in verbiage, iterate over vertices, right? If we iterate over vertices, then player to vertex, first line. Maybe by not caring yet about the next raycast angle and see it as a different mesh and try to find the next hit and the next hit of the past ray. Yeah, not using the mesh information. Well, actually, let's just code out the naive approach here, and then we'll look at what it does. I think that's good enough. And then we can always like make changes to it. But let's get something working. So in this case, if we have our raycast and our hit, we're iterating over all vertices, over everything else that we could possibly hit, to find that intersection, to do the bounds checking. And now we have our line strip and the hit. So these intersection points are all of the intersection points on the ray that we will end up using. So we need to return those, right? That's the only thing this whole calculation is doing. So let's call this hits. This is currently flat mapping, but we're not returning anything. Well, no, it's not flat mapping. Sorry. Hits, this is flat mapping, and then we are effectively mapping with our, what do we call this? Vec2, Vec2. This is other. For all positions, flat map over the mesh vertices. This gives us all of the walls. Here's our wall. Let's rename this to wall. Because I think that's better semantically. Right? We map over the walls, which makes this our ray. How often do we use this construction of it? Once. Not a problem. So if we have an intersection point, this is going to be a filter map. Technically, this can be a question mark instead of this extended let sum or let else. But I want to see that log if this ever happens. It doesn't matter that we're returning none here because there's nothing to do. But I want to see that if it ever happens. So this then, we return some intersection point, right? We could make this a let chain instead. I'm not a huge fan of let chains, if I'm going to be honest. I know a lot of people like them, but okay. So we will get all of our intersection points returned. That's all of our hits. I think we only need the hits. So for the vertex that we are currently processing, we have all of the hits for that current vertex. Can we I feel like maybe we could cut our visualization short If that makes sense. Like we're just raycasting through things. What did I say we were going to do before I got into this? I said we were going to do the distance of all closest hits. So let's just start with that before I go off track again, because I could easily get distracted. Perimeter. Raycast against all other walls from player position. Other walls doesn't make sense anymore because we're not using other as a variable name. So raycast against all walls from player position. Return hits. So we have hits here in this iterator. So we do dot min by AB. Does it need to be AB? Is this accurate? I don't know if I want min by. Let's check iter tools. Set min by key. Min by. Why does that not have min by key? Rust iterator must have the min by. Rust iterator. Min by key. I don't really want min by key per se. Oh yeah, it gives me the opportunity to operate on it. We do want min by key. I guess we don't have a key, do we? Min by key doesn't require us to, so I think we're still going to do min by key hit dot distance. Player position. Cargo run visibility 2D mesh. Or does not implement it for F32. We can do float ord. Right? Does that fix our problem? Probably not. So we'll have to do min by hit A, hit B. Player position. This needs to be total comp, not comp. I just happen to know that. Okay, so then I want to draw these circles. This is going to be closest hit at the moment. And we're just going to draw a circle at the closest hit. This is not the right thing to do. Option, yes. Let's just assume we have one and our program will crash if we don't. So this is interesting. Because we miss out on our distance raycasts for sure, right? But this would build a mesh for us. So let's build the mesh, because I think we're running out of time on the stream. So let's build the mesh. We'll end up with a manually constructed ray mesh that has similar problems to the one that we originally had, but has the ability to actually solve them. So these are all the closest hits. Right? Closest hit. I don't know that we need to turn this into another iterator. I like iterators, but I know that a lot of other people have a hard time reading nested iterators. So let's make what, a vec of hits and then window over it. To build the mesh. Hits dot push closest hit dot unwrap. Unwrap is not always going to be our friend here. Right now, it's not a problem. I don't know that it will never be a problem. I'm just using it as kind of a shortcut. And then we get out of that loop and we have hits. So hits.iter dot tuple windows. Is it circular tuple windows that we really want? Probably, actually. Hits are, I think, going to already be sorted because of the way that we went around this, but I don't know that for sure, actually, at the moment. So for hit in hits, let's just check this. Because we didn't run a sort, so we would have had to just kind of like not have messed it up. 3, 2, 0, negative 3, 2. This looks sorted to me. So we're going to assume it's sorted already. I'm going to encode that assumption. Hits.iter dot circular tuple windows, right? I think this is enumerate. No. because hits needs to be combined with the player position. So we actually need to iterate over all groups of 2 of the hits. But while we build that up, we are going to be building up our triangle list. Right. Triangles equals this vec. What did we build up for our other triangle? This was triangle bases, right? Triangle bases was this. So let's just make this the same thing, because I think that's what we're going to have to throw into our mesh. Itertools, every time you see it, you're reminded of what a gift it is. Itertools is fantastic. I also love seeing functions like very slowly move into main or like upstream. Like one day I won't need to actually use tuple windows, because array windows and other Windows functions have made it upstream. They're just nightly at the moment. And then we'll get to use like an array of 3 instead of a tuple, which is very cool. So triangles, we're assuming hits are sorted. Hits.iter.tuple windows, I think, because this is just going to be the full set of triangles, right? Is that true? I think we need to connect the last one too. I think this is actually going to be circular tuple windows. So for hit A, hit B, in this triangles dot push, we could just map this. This doesn't need to be. Do we need to do the indices at the same time? No, because the indices are just going to be one giant list. We're actually not going to have the indices even, so we can just do this. Dot map, hit A, hit B. We're going to collect this at some point. We're going to build like XYZ out of this somehow. This is going to be, I think, player hit A, hit B. Player BA is actually the way that the triangle is going to get built. And we have 2 vec2s, so we need a... Why is this a vec of... Oh, this is a vec of 3-dimensional points. Right. So this is going to be flat map. Because what we actually need is player position. Player position. We can do as array, right? I'm not like totally blanking on that. To array. Yeah, vec3 to array will give us a 3-dimensional. So really what we need to do here is player position. We're doing a little bit of extra work here. We're not really optimizing our mesh, but right. Array 1. Array 2. Array 3. So we don't need to mute triangles because we already have it. I do like building things up with collect rather than like stuffing them into mutes, but I know that other people have different preferences too. So we've got all of the hits, all of the closest hits, right? We iterate over those circular tuple windows to get ourselves just over the edge into the last hit to close the gap. And then we have player position, hit B, hit A. So we got a counterclockwise triangle. And then where's our mesh? I think we have the mesh logic like way down here. So I'm just going to copy what we have here and bring it up over the old code. The fact that Rust Analyzer formats code inside of comments in ways that code doesn't get formatted always feels weird. Oh, that's not what I want to do. So we at least have something that looks a little bit like it's supposed to be correct. It's just very much in the wrong position, right? So the question here is, why is it in the wrong position? Is it because we need to subtract player position from each of these hits? And that does look correct. That looks a little weird. Maybe we should be extending this with 1. Let's see. This is... You actually came to ask a question. You were going to do a falling particle sand sim as a fun first Bevy project. Just go for it, or something like Snake to get used to Bevy. I think falling sand... How are you going to do your falling sand project? Is my main question. Your falling sand project, like, it's not bad, right? Like, it's not a bad idea. But for falling sand, I find that people seem to be doing more compute shaders and stuff like that for performance reasons. So if you're going to do like a CPU based entity per sand particle kind of deal, entity per sand particle is probably going to be a little bit of overhead unless you're just doing it to like learn a little bit about Bevy. So that's kind of my comment is basically like, if you're going to build a falling sand engine, you're probably not going to use as much of the entity component system for individual sand particles as you might expect. You probably are going to want to go into compute shaders and stuff like that. But if you're going to do like a very basic one on the CPU and try to just do it with systems or whatever, and you don't really care all that much about, you know, having a million sand particles or billion sand particles, then it could be fine, right? It's all about scoping the project correctly, is what I would say. Snake is also a good option if you want to get into it. I think if you're going to get discouraged when you start building the sand project because it doesn't feel like it quite fits, then maybe go for something else. I think it could be very easy for you to be like, oh, what should I, like, should this sand particle be an entity? And the answer is, are you doing this as a learning project or are you doing this as a production sand engine? If you're doing it as a production sand engine, you probably need to like think about storing the data in a different way and doing compute shaders to take advantage of the CPU for the falling sand simulation. Compute shaders are not really like something that I would be like, oh yeah, just go do that as a beginner. So if you have experience with shaders already, maybe. If you don't have experience with shaders, maybe avoid that for the moment. But really it's up to you. If you're just going to do it as a learning project and it doesn't need to be completed, it doesn't matter which route you take. You can just kind of like experiment. But keep in mind that if you do something simpler, if you do something that like you might find on like an Atari 2600, that will be more directly translatable in a more obvious way. That's my thoughts. I think it's yeah. Falling Sand Engine to me screams compute shaders, which isn't necessarily Bevy, right? If you're trying to learn the ECS, writing a compute shader isn't necessarily the way to do that. But there's nothing wrong with the project. That's a solid assessment. Actually, you hadn't considered you would get assessed with the performance and spend time playing with shaders all day instead. Thanks for the reminder. Yeah, I mean, playing with shaders is super fun, right? I love shaders. But if that's not what your goal is, yeah. Nth is correct. Bevy is a game of life compute shader example, which is actually very helpful for getting introduced to how to work with compute shaders. The documentation beyond that isn't great, I will say, for compute shaders. Like there's no like series of compute shader examples that build you up into learning how to use shared storage buffers and stuff. You can figure it out. There are like scattered things, but you will have to do some like digging and stuff to figure it out. Rendering, and especially like advanced rendering, is not something that is particularly well documented at all, not even including Bevy. But also in Bevy, rendering is, or advanced rendering is not particularly, like there's no step path to advanced rendering right now. It's very much like you read what Bevy does and you see what other people have done in their advanced projects and you put something together out of like learning from that. You've been so unmotivated lately and been dealing with a particularly nasty cold. I mean, sleeping if you're sick is fine. Sleeping if you're sick is like good. Okay, so this is an interesting behavior right here. I don't know what I did to my little player. My little player and my mouse don't seem to be in the same position. Right? Like, why is... I feel like that's really interesting as a result. Why is that happening? Flat map, first chord should be 0, not the player position. Mix of local global. Flat map, first chord should be 0. Oh, yeah. Yes, you are right. Thank you. Because this is... why is that an issue? Oh, because it's not a float. Thank you. It was going to take me a second to realize that between talking to chat and looking at it. There we go. Okay. Now it looks like it's supposed to look. And now we're not getting that weird behavior that we were seeing either. Whee! Here's the mesh as it gets created. You can get that spider webby effect. So this is very good. I'm very happy with this in general. The parts that I'm not happy with are we're not extending to the edges, which is a similar problem that we had with the original visibility mesh. But it's actually fixable for us now because we have those raycasts now. We have the hit distance for these things. And I think it's going to be something along the lines of if we're building the hit, we have to do either like a forwards look ahead or a backwards look to figure out if there's a hit on the same surface. And if there's a hit on the same surface, then we use that as the triangle position. And I think that clears it up for us a little bit. I don't know. I think starting, the two things are starting a new one. So this ray right here, how do we get this to be extended? And this situation where we have like the ending in a spot. Right, this ending here. Because this, yeah, anyway. Overall, I'm much happier with this approach. This approach makes so much more sense. I think that rewriting this was the right move. Doing the math is not my strong suit, but does work out. I think I need to leave a little bit of a note here about what this math does. I think this, we could re-enable this to check out the rest of the lines. Right? So you can see we have all the information we need. We just need to be filling in these triangles slightly differently. Right, like the right edge of this, as we're leaving this mesh, needs to extend to the next hit. And then once we're on that hit, we need to do another calculation here. I don't know. I'll think about it. I'm kind of dropping on mental capacity at the moment. But our visibility mesh is coming along. We just need to use the raycast information that we now have available to us. And then this becomes like an actual visibility mesh. And I'll push up the code for this for the people who are, following along at home. I formatted everything. Let's add cargo stuff, and let's add the visibility stuff. And I think everything else I can do on a second pass. Bitmaps, hooks, candy cane stuff, edge detection. I need to run the formatter, obviously, over the project. But is this README committed right now? Yes, it is. I don't want a GAU. I want GA examples, visibility to mesh, README. This is the problem with running cargo format in a directory that I've not formatted yet. Cool. I'm happy with this. I hope you all enjoyed it. We will finish this up, and then I'll talk about like the actual approach we used to extend these raycasts at some point. Next stream is probably going to be Monday. So we're going to skip over Sunday because I'm going to take some time for myself and do some scripting and recording and stuff. And then I will see you all hopefully Monday. Thanks for hanging out and participating in chat, and hope you have a great rest of your day and rest of your weekend.